Have you ever stopped to think that maybe the way we've all been taught to learn, well, maybe it's not the full picture, or perhaps even a bit outdated?
It's a big question, right? Education's followed a pretty similar path for ages.
Exactly. But what if the most powerful tool we have for learning our actual brain hasn't really been the main focus?
Uh-huh. That's sort of the hidden potential, isn't it?
Well, today we're doing a deep dive into something pretty revolutionary. It challenges all that conventional thinking. It's called the Taxshila Model, and specifically this idea of a learnography.
Learnography. It sounds different already.
It is. We're digging into the research from an article, Training the Brain, the Core of Learnography, by Shiva Narayan Taxshila Page. It just came out August 2nd, 2025.
Fresh research, then. That's always exciting.
Our goal here is to pull out the key insights for you, to help understand how we could maybe transform how we acquire knowledge, how we hold on to it, and how we actually use it.
Right. The application part is key.
And we're really focusing on this core shift that people talks about, moving from just teaching the mind to actively training the brain.
And that shift is becoming more and more critical. You know, the demands of learning today in the 21st century, they're accelerating.
Things change so fast.
They really do. So we genuinely need something transformative, not just tweaking the edges, but really rethinking how knowledge gets in, stays in, and becomes useful.
So this research, it's not just suggesting small changes.
Not at all.
Yeah.
It's arguing we're facing a fundamental challenge to, well, the very foundations of education as we know it. It forces us to reconsider everything.
Okay, so let's unpack that traditional model first. Picture a standard classroom. What's going on? Teacher up front, students listening.
Yeah, taking notes maybe. We all know that scene.
The Taxshila research points to this setup and says, hold on, the core issue might be that conventional education is built on pedagogy. Teaching is dominant.
And the student often ends up being pretty passive in that equation, right? Just receiving information.
The paper suggests that model, while familiar, might just be inherently limited.
Exactly. It's very teacher-led. The emphasis is on delivering content, which often just leads to, memorizing things for a test, rote learning.
And then standardized tests to see if you remembered it short term.
Right. And the focus is on the student's mind. Mostly, it's activating the prefrontal cortex for that conscious kind of auditory processing, listening.
The study calls it a talking classroom.
Uh-huh. And that can create what they call a dependency loop. Students just wait to be told the next thing.
Waiting for instruction. Yeah, I can see that.
And a key finding they highlight is that this reliance on just hearing and verbal processing, it often only leads to a sort of surface-level, short-term understanding.
It doesn't stick.
Often, no.
Yep.
It fails to create that deep, lasting retention. And maybe more importantly, it often fails to translate into actual real-world skills.
Think about lectures you've sat through. How much actually truly stuck and became usable knowledge?
It's a sobering thought, isn't it?
And this is where it gets really interesting. The Taxshila model brings in its bold alternative, this thing called learnography.
Okay, learnography.
They describe it as a framework based on the brain. And it literally replaces traditional teaching with what they term learner training.
Learner training, not teaching. That's a deliberate choice of words.
It sounds like a complete rethink of how learning should even be structured.
It really is. Learnography, as they define it, isn't just another teaching method. It's a neurocognitive transfer system.
Okay, neurocognitive transfer system. Break that down.
Think of it like a pipeline, a really efficient one, designed to get knowledge from the source, like a book, directly into the brain's deeper memory circuits.
Bypassing the passive listening part.
Exactly. It shifts the whole center of gravity in the classroom, away from teaching, towards knowledge transfer, and something they call brainpage making.
Brainpage making, what's that?
We'll get into that.
Yeah.
But they also introduce the idea of a gyanpeeth.
Gyanpeeth.
Yeah, it means a knowledge-centered learning space, a place where learners are actively building their own knowledge modules.
Building them themselves.
Correct. And here's a crucial point they make. Unlike conventional education, the Taxshila model explicitly says it is not education. In the traditional sense, it's gyanpeeth learnography.
So they're really drawing a line in the sand. This is something fundamentally different.
Absolutely.
So this distinction, teaching the mind versus training the brain, it's not just words, is it? What's the deep difference neurologically, practically, that makes this so potentially transformative for you, the learner?
Oh, it's a huge difference, both philosophically and neurologically. Let's lay it out simply.
Okay.
Traditional education, Pedagogy, it teaches the student's mind.
Right.
It's teacher-centered, uses verbal explanations mostly.
Creates that dependency we talked about.
Yeah, dependency on instruction. It's the talking classroom.
Mm-hmm.
And memory often relies on repetition, just hearing it again. Neurologically, it's mainly hitting the prefrontal cortex, conscious thought, working memory.
Got it. Mind-focused. Now, learnography.
Learnography, or gyanpeeth learnography, aims to train the learner's brain. It's learner-centered. It uses motor cognitive tasks involving movement and thinking together.
Ah, so physical action is involved.
Critically involved.
Yeah.
It's driven by self-directed training, creating what they call a brain page classroom. And retention happens through actively creating these brain pages.
Not just receiving information, but building it.
Precisely. And neurologically, this is key, it specifically activates different brain areas. The motor cortex, the basal ganglia, the hippocampus, the cerebellum.
Those are involved in movement, habit, long-term memory, coordination.
Exactly. Areas crucial for deep embedding of skills and knowledge.
So the core insight is?
The core insight, and it's powerful, is this quote from the paper. While the mind listens, the brain does.
Wow. Okay. The mind listens, the brain does.
That shift changes everything.
Yeah.
The classroom transforms from a place of just, passive explanation to an active workspace, a place for doing, for mastering, for self-driven learning.
It's like the difference between someone telling you how to ride a bike versus you actually getting on and doing it.
That's a perfect analogy. One leads to understanding, maybe. The other leads to ability.
That makes a lot more sense now. So how does this idea, moving from mind listening to brain doing, actually look in a real classroom? If I walked into a gyanpeeth, what would I see? What's different? What are learners doing?
You'd feel a different kind of energy immediately. It's not silent like a library, maybe, but it's a focused quiet. A hum of activity, not a lecture drum.
Okay, focused activity. Doing what?
Learners are building these things called brain page modules.
Right, brain pages. Tell me more.
Imagine them like detailed mental blueprints of knowledge, highly organized personal multisensory constructs in your own mind for every concept, like building your own internal wiki, but much deeper.
How do they build them? Just by reading?
No, not just reading. It's through self-directed rehearsal and a specific kind they call cyclizide repetition.
Cyclizide repetition. Sounds complex.
It's not mindless rote learning. It's described as a very structured cyclical practice designed to embed knowledge deeply and accurately. And critically, it involves intense, motor-driven engagement with the source books.
Motor-driven, so they're physically interacting with the books somehow.
That's the idea. Physically engaging with the material, not just passively scanning text. Learners aren't taught in the old way. They are actively trained.
Trained, not taught.
Right. They become active participants. They even become small teachers themselves through rehearsing and internalizing the knowledge.
And the teacher's role, what happens to them?
It changes dramatically. They're not instructors delivering content anymore. They become facilitators, moderators, knowledge regulators.
So guiding the process.
Yeah, exactly. Helping learners navigate their own discovery and brain page construction. So the whole classroom dynamic flips. It becomes silent and productive, not noisy with lectures.
Silent and productive, that sounds very different.
And the learning itself gets internalized through, well, the paper uses terms like motor science, using your body and senses, procedural memory, that how-to memory for skills in spatial dynamics.
Spatial dynamics, using space.
Yes, understanding how physical space and moving within it can actually help memory and learning. This includes space-based learning, where the classroom layout and how learners move within it helps attention and even emotional regulation.
Wow. So the physical environment matters too.
Very much so. And they have other structures too, like miniature school systems to build teamwork and leadership, and something called the definition spectrum for ensuring precise understanding.
It really is a complete system overhaul, focusing on active doing, physical engagement, brain processes. So for you, the learner listening right now, what are the big wins? What does the study say are the concrete advantages of this approach?
The benefits they identified are pretty compelling. First off, faster learning combined with much deeper, longer-lasting retention.
Because it's encoded differently in the brain.
Precisely. It's built into those deeper procedural and spatial memory systems. This leads to real ownership of knowledge. Learners aren't just borrowing facts, they're creating their knowledge structures.
And that must boost confidence.
Hugely. Boosts self-esteem, curiosity, and fosters a genuine lifelong learning mindset. You also see a big reduction in dependency on external teaching. Learners become more autonomous, self-directed.
They learn how to learn, essentially.
In a very practical sense, yes.
Hmm.
And through those miniature school models they mentioned, practical leadership skills emerge naturally.
Interesting. What else?
The focus shifts towards functional intelligence, not just knowing about something, but being able to do something with it. Problem-solving fluency, real-world application.
Less theory, more practice built in.
Right. They also report reduced cognitive load. Because the process is more efficient and taps into different brain systems, it frees up mental bandwidth, leading to better focus and efficiency, especially on complex problems.
That sounds huge for tackling difficult subjects.
It could be. And perhaps one of the most appealing benefits they describe is increased engagement and actual joy in learning, creating a happiness classroom culture.
Happiness.
How? Through the active physical and cognitive engagement, the sense of mastery, and apparently significantly reduced stress compared to traditional methods.
Less pressure, more doing.
Seems to be the idea. Plus, they found it improves equity and inclusion. Because it uses physical action, spatial memory, and repetition, it benefits a wider range of students, including those who might struggle with purely lecture-based learning.
So it's more adaptable to different learning styles?
It appears so. And finally, a really practical point. The study suggests the model is scalable and adaptable. It can be implemented within existing school structures, provided there's proper integration and training.
So it's not just a theoretical ideal. They see a path to implementation.
That's what the research indicates, yes.
Okay, those are some really powerful potential benefits. More effective, deeper, more autonomous, even happier learning. But let's zoom out. If this model works as well as the research suggests, what does that mean for the bigger picture? For schools, teachers, maybe even national education policies? What are the major challenges the research sees in actually doing this more broadly?
Well, the implications are massive, and the hurdles are definitely significant, though the paper suggests they're not impossible to overcome. First, education systems would need a serious rethink of their core classroom methods.
Questioning pedagogy itself.
Fundamentally, a critical look at models centered purely on teaching. Teacher training, for example, would need a complete overhaul.
How so?
Shifting focus from teaching instructional strategies to training teachers how to be these facilitators, these guides for brain page making, that's a different skill set.
Absolutely. And curriculum.
Curriculum design would have to change too. It needs to support this book-to-brain knowledge transfer through task rehearsal and these cycle-side practices we mentioned. It's not just about listing facts to be learned anymore.
You'd need materials designed for this kind of active engagement.
Exactly. And even school buildings. The architecture might need rethinking to better support space-based learning and collaborative active work.
So it goes right down to the physical bricks and mortar, potentially. That's a huge list.
It is a deep transformation. Assessment also changes. How we measure learning. It can't just be about recalling content.
You'd need to measure, what, brain page quality?
Yes, things like brain page quality, teamwork, problem-solving fluency, the ability to apply the knowledge. It's a different way of evaluating success.
This really could potentially revolutionize national education policies then, if it offers a scalable model that aligns better with 21st century needs like critical thinking and adaptability.
That's the potential the research points towards. And it also opens up new ways to integrate technology, effectively using digital tools, maybe AI, to help create, refine, and track these brain pages.
Okay, so ultimately it sounds like it reframes the entire purpose of school.
Completely. Moving away from schools as just institutions for teaching minds towards becoming training grounds for knowledge transfer, brain development, and skill-based mastery.
Training grounds. That's a strong image. What's the biggest barrier then?
Probably inertia. Overcoming deeply ingrained habits in teaching and learning and the sheer momentum of existing educational systems. It requires a significant mindset shift from everyone involved.
Okay, so wrapping this up then, the core message here seems to be that the Taxshila model, this idea of learnography, is a radical departure.
Truly transformative, potentially.
It's about fundamentally shifting from just teaching the student's mind to actively, purposefully training the learner's brain, using different processes, different parts of the brain.
Yes, it's both a philosophical shift, what learning is, and a neurological one, how the brain actually builds lasting knowledge and skill. And the research suggests this leads to much more meaningful learning, much stronger memory.
And potentially that happiness classroom culture.
And that culture of engagement and reduced stress, yes. It redefines how we could acquire knowledge, keep it, and actually use it effectively.
So as you listening reflect on your own learning journey, maybe think about this question, which comes directly from the source material's call to action. Are we teaching students or are we training learners?
Hmm. Teaching minds or training brains?
The Taxshila model suggests the answer we choose will profoundly shape the future of learning for all of us.